Well, thank you guys. Thanks for having me, Nate. Again, Jason Schley, East Central South Dakota. Grew up on a farm there. I always tell everybody I live right on Highway 281. If I go 40 miles west, it was 100% pasture 35 years ago, 100% row crop today, but always in a drought, it seems like. It doesn't matter. We might get 2 good years out of 10. If I go 40 miles east, it's just the opposite. We're almost like Minnesota. We raise a terrific crop. We can hit 250, 260 on a good year. So I'm kind of right on that borderline. What brought us to where we're at today, I guess, is I was a crop consultant. I started as a crop consultant back in 2000, I guess. We built up a business there locally as a couple counties wide. We were doing about 150,000 acres. Needless to say, I could tell the future was definitely in fertility. I could watch growers that were good at it. I could watch growers that were bad at it, and just watch how well they withstood stress, okay? There was a gigantic difference between guys that knew what they were doing with fertility or had manure in their rotation, and then when we hit stress. And again, we're always in stress in South Dakota, right? So started really digging into that, and what I did is it was just kind of I thought it was a better way to learn. I read. I mean, at that time, I still that way today, I guess. I probably read 5 hours before I fall asleep. But anyway, I couldn't find the information I wanted. So what we did is we built a system that we would take 1/1000th of an acre across this 130, 140,000 acres. We had 60-some growers involved. And we would take whole plant studies and tissue tests and compare it to that soil test from that 1/1000th of an acre. All we were trying to do is better understand the soil system so we could do a better job of predicting what that soil would give that crop throughout the season. That was the entire goal of it, okay? I'll fast forward. We're into year 2, and we're already seeing things that just don't add up. So finally, year 3, I send it to Purdue, actually this data to Purdue, spent a lot of money on this data to have them go through it and determine, you know, give me correlation factors. What is affecting potassium? What is affecting phosphorus? And how good are our correlation numbers, right? Because we were running different extractions. Needless to say, when it was all said and done with, the data said that we were very poor at predicting things based off a soil test. That was the truth. Most universities actually told me, well, quit using tissue tests. What's that do for you? I'm like, I'm taking the whole plant, I'm taking the tissue. There's no way it's lying to me. I know exactly how many pounds it took up on 1/1000th of an acre. There's no way this data's lying. It's the soil test isn't right. And very few people agreed with me, truthfully. So finally, I just kept searching, and through time, I found a guy by the name of Rick Haney. He was in Temple, Texas. This is back in about 2010-ish, I'm guessing. And then I found a guy by the name of Will Brenton out in Maine. Rick Haney was really focused on understanding, you know, hey, we've been looking at inorganic nutrients for the last 60, 70 years in our soil tests, but just because it's inorganic, does that mean it's available to the crop, right? So he was looking at different exudates from the roots, trapping every crop across the nation, basically, understanding what happens when that plant grows up. It captures sunlight. After it's captured sunlight, it converts it to sugars through a process called root exudation. It then feeds the microbes, right? I'm a plant, I capture sunlight, I convert it to sugars, the sugars go into my root. That's what I do, okay? Needless to say, he was capturing what was in those exudates to understand why do some areas release much more fertilizer than others, even though the standard soil test was the same. So the following year, we started using 3 labs. And we did the exact same thing. Went out there and did this 1/1000th of an acre, took the whole plant, took the leaves, took everything throughout the season. And we discovered that biology was trumping a lot of what our soil test said. Meaning that, especially phosphorus, there was way more correlation to how active my soils were as far as biological activity and how much carbon were in there than any part per million test that we looked at. So it was really eye-opening. And again, I went back to universities, I shared everything I found, and nobody really cared. So that's what actually started Next Level Ag, it was the fact that I couldn't keep sending to 3 labs. We needed to do something about the accuracy of a soil test. And something that was just, and I say this at every meeting, but you guys don't know me, so I'm going to say it again. I had an old-fashioned grower in this group, and what I mean by old-fashioned grower is just simply that he was a rotation farmer. I'm sure you guys know what I mean. I mean, he would go spring wheat, winter wheat, sunflowers, corn, alfalfa, oats, whatever his rotation was, it didn't get changed by markets, okay? It was just, that was right for the land. He was probably 65 at the time. I still scout for him today. He's 85. I had a young guy that come back to the farm, okay? He says, you've been scouting for my dad for the last 10 years. I still want you to do mine, but I think you need to do a better job on phosphorus. So I want you to put, on our base recommendations, we don't want to be less than 45 part per million phosphorus, okay? So what we did is changed all of the soil tests. We got them built up. Through these studies, we were finding that this guy that had 45 to 100 part per million soils was actually taking up less phosphorus throughout the season than this old-fashioned grower that had a great rotation but never applied phosphorus. He had 3 to 7 part per million soils. The first thing that really opened my eyes is why didn't these 3s and 7s, we're taken from the exact same spot, right? Year after year after year after year. Some of these guys we've been testing for in the same spot since 2022, or 2002. And needless to say, these 3s and 7s, they should go to 0. I'm watching the plants take up 100 pounds on a per acre basis. Why aren't these soil tests going down, right? Something to this. The other big question is how in the heck can 100 ppm soil outperform a 3 or 4 or 5? And the reason is because I didn't tell you one part of that story. That young grower that came back, he was a market farmer, meaning that if he could make money on beans, he'd go beans, he'd go beans, he'd go beans, he'd go beans. So very little diversity in his rotation and a lot of tillage. Needless to say, when you push soybeans hard, they're a net negative crop for carbon in your soil, and then you add tillage every year. Basically what you're doing is you're burning the carbon out of that system, okay? This old-fashioned grower, on the other hand, had some of the highest carbon that I had seen. In fact, to this day, if you've ever been to soil health meetings and heard Gabe Brown or any of these guys, his levels would be very similar to that without cover crops, just with his rotation. So again, he had 3, 4, 5 part per million, but he got tremendous amount of phosphorus into the plant. And what we need to do is understand that we shouldn't care what our soil tests say for parts per million. What we really should care about is how well we are at turning phosphorus that we apply to phosphorus in the plant. And I'm not saying this based on our data, because our data is even worse than this, but universities say for every dollar we spend on phosphorus, we get what? How much? What do you guys think? Is it $1.50 back, dollar back, 75 cents? What's your anticipation of that number? More or less than $1. If we're spending $1, do we expect to get more than $1 back from that phosphorus dollar? I hope so, right? But we're getting about 30 cents back for every dollar we spend, and that's across the whole 50 states. This isn't our data. Our data says it's about 18 cents for every dollar we spend. But the point is the reason that happens is when we're applying phosphorus, we're applying available phosphorus, okay? We're applying, when I put 1034O out, when I put 1152 out, when I put DAP, you're applying inorganic phosphorus. Again, we've been measuring inorganic phosphorus the last 50, 60, 70 years. Why? Because the plant recognizes inorganic phosphorus as plant food. That's what it takes up. It doesn't look at the organic nutrients. We've got to convert organic nutrients into inorganic nutrients before the plant can recognize it and take it up. But what the soil test doesn't tell you is, am I calcium phosphate, aluminum phosphate, iron phosphate? What am I? I'm still phosphate, so I'm being measured as inorganic. But if I meant any of those molecules, basically that plant doesn't even recognize me as plant food anymore. Okay? So when I apply 1034O in a 2x2 or whatever I'm doing, it's available for that 7, 10, 14, 21 days, and then boom, she's tied up. What unties that system and what actually creates the availability after that is again, bacteria and fungi. Bacteria and fungi, and I'll use bacteria for a better example because I've got a lot of data on this. When bacteria are working hard for you, your HT3, what Christina was talking about, a measurement that we look at in the lab to understand how much carbon dioxide is being released, will ramp up. When they're happy, they'll ramp up. So we'll get higher CO2 because they're more active. Well, the more active they become, the more enzymes they create, okay? And enzymes are actually what are releasing this phosphorus and a lot of our nutrients back to our crop. So if I've got a calcium phosphate molecule, again, it showed up in my soil test as phosphorus, so I'm happy, right? But it's not available to crop because crop didn't recognize it. So something's got to break the calcium away from that phosphorus so the phosphorus again can go into the plant. And what's actually doing that on a daily and by the minute basis is in enzymes. Okay, so the happier we create an environment for our microbes, the more enzymes that created, and we can start spoon feeding our crop, you know, hundreds of years of phosphorus that we have in our soil. So I'm never against phosphorus or any fertilizer source. I'm just trying to explain that everything in our soil system is a cycle. You've got basically 3 major pools of fertility. You've got a total pool, which on phosphorus will oftentimes be 1,800 pounds, maybe even 2,000 pounds in this world. And then you've got your standard ball, which is a lot smaller. Roughly 5% of that total is going to show up in your Bray, Malick, Olson test. And then you've got a plant available pool, which is just a dot. It's going to be less than 1%, okay? And that's the pool that I focus on the most, but our lab looks at all 3. The reason our lab looks at all 3 is because that system cycles. It goes from the big ball to the middle ball to the tiny ball nonstop. Once it gets available again, boom, it's the weakest kid in the playground. It's going to get picked on again. You're going to have aluminum, iron, calcium, everything fight and lock it up, and then it goes back to the total pool. Okay? So it's a never-ending cycle that you have to understand, because I'll give you a great example. I've got a grower that's been in every TV show that's known to man for corn. It's got extremely high phosphorus levels, still applies phosphorus 3 to 4 times a season, even though his phosphorus levels are unbelievably high, okay? He has to apply it. Why? Because just because you have high phosphorus levels doesn't mean it's going to stay in the availability pool. And if you've over-fertilized for years, what you end up doing is slowing that whole cycle down, meaning that you lose some of that gas exchange that we talked about earlier. I'll give you an example how you lose that gas exchange. If I apply a bunch of phosphorus and I've got a bunch of calcium, what happens? Have you guys ever put phosphorus and calcium in the same tank in your starter? It turns basically to a sludge and then to a rock, right? It crystallizes. Well, that chemical reaction is happening in your soils as well. We just don't have to deal with it. But what it does is slows down our microbial activity, because all it is blocks the salt and it ruins the gas exchange, right? Does that make sense to you guys, what actually is happening in your soil? And if, again, stop me at any point, because I can just ramble for hours, and if you're not understanding it, it won't do us any good. But the driver of everything I look at is predicting what's going to become available based off of, again, how much carbon we have in our soil, not organic matter. I don't care about organic matter. Yeah, it's good. We need it. But it's not what's driving the system. You know, we've probably all been taught that we can estimate how much nitrogen we're going to get into the system based off organic matter, right? I mean, a lot of guys talk about that. If you got 4% organic matter, credit 40, 50 pounds. What we do is actually measure the organic nitrogen in the soil instead of estimate it based off of your organic matter, because there's virtually zero correlation between mineralization and organic matter. And I mean virtually zero correlation. So whoever taught us that was way wrong. Where it really ties together is when you're looking at organic and then looking at how active our soils are. What that's going to tell you as 100% is how many pounds I can get for free if I'm not flooded, if I'm not in a drought. That's what it'll tell you. It's a direct measurement. You look at your activity level of your soil, because they're the ones going to break an organic nutrient into inorganic. And the higher volumes of again, bacteria and fungi are going to drive that HT3 number. So the higher they are, the more credit you get, or the more mineralization that will happen in your system. So much like Nate, he showed me pictures of a healthy soil and healthy soybeans, and he says, man, the soil test didn't say much different. But what did stand out to me is the fact that I had higher respiration in that soil, okay? Why is that important? Because 100% of fertility is more effective and more efficient if it's got bacteria or fungi carrying it to the plant, or having that association with the plant. Once we want the chemistry to do all the work and the biology not to help, what we do is we lose that. And we lose a lot of our effectiveness and our efficiencies. That's why, again, universities say we get 30 cents for every dollar that we spend on phosphorus. The reason being is because we're making chemistry work on its own and create that association with the plant, which in all reality, if you'd have thought of 50, 60, 70 years ago when we had a lot of carbon in our soil, we got by with a lot less fertility. Why? Because we had more microbial life. We basically are burning the carbon out of our system, the way we farm and the way we fertilize, to the point that our soils aren't quite as effective at releasing these nutrients as they once were. You know, and my dad's always told me, you know, think about, he always said this. He says, man, if you can find land that drains well but hasn't been pushed very hard, it's amazing what you can do with it in 2 or 3 years. And then he would say, on the other side of that coin, if you've got a guy that over-fertilizes, over-tills, and you take it over, it's very hard to change that land. And my example of that would be, if a guy calls me and wants to win a contest, we put a lot of effort into this. And if he's in sands and he's got high carbon, I'll take that. We can win fast. If we had heavy soils, like a lot of you guys have, it's a lot harder to change that, because you're holding so much more fertility. So the blanker the slate, the easier it is to change, if that makes any sense to you guys. You got it. A lot of times we're so worried about part per million values that we forget that without, again, I'll explain it best like this. If carbon is your energy in your soil, which it absolutely is, it's the fuel that runs the entire system, guaranteed. Carbon is the energy, okay? And you're building fertility up. Once you get to a point, you're going to see fertility keeps going, this will stall out, and then you'll start to see your carbon come down. It's the fact that we plug the system up so we're not breaking organic matter down into this water extract organic carbon anymore, and we're losing the enzymes that are responsible for that. And once we do that, we run out of gas. If we run out of gas and we've got all this fertility over here, we can't cycle this fertility. We'll never move the numbers in our soil test because it won't go out in the plant. Again, I'll use a better example. If I did this 100 times in my life, I'll tell you 99 times it's going to be this way. So if a grower says, hey, I got a soil type out in this field, and one area of it yields really well, one area of it doesn't yield very well, will you please go soil sample that for me? So I've done this for 25 years. I go out there and soil test it, and every grower is excited to get the results back because he thinks, man, that's going to show me why it's so much better. There'll be higher phosphorus, higher potassium, right? On 99 out of 100 times, it's going to come back that high yielding spot is actually lower P, lower K, lower calcium. And the reason why, it's because that soil did a great job for the last 100 years of releasing it. It's not about building it. It's about how well can I release it. I'm the soil. I need to release it. If I'm not releasing it, who gives a crap? I mean, again, you don't want to build a bank account that you can't access, right? You want a checking account. You want a debit card. You want to be able to access every dollar you save. Same thing with soil system. If you're just going to worry about ppm values and bank these ppm values and you can never get access to it, what good does it do to build them? What we need to do is build a system that can access these nutrients. Otherwise, again, for the last 100 years, we've just been building it up. I was in a meeting last week in Iowa, and this older guy come up to me. I've been doing these meetings for this guy for a long time. It's a land management system. It was right before I came to that meeting in Omaha with you, and I think I maybe told you the story when I was down there, but needless to say, we were sitting there and this guy says, will you look at my soil test? And I said, yeah, I'll look at it. And again, I should explain myself, but this land manager manages a ton of acres, and he has me come in and talk to his tenants every year. Well, anyway, this grower wanted me to look at the soil test, and it was an 80 he'd been farming for 25 years, okay? And then this land manager bought an 80 that connected to it. So they yanked out the fence, and for the last 10 or 11, 12 years, the grower didn't know. He had been farming it for this land manager, and then the other piece he had owned, okay? Well, the piece that he owned, he had sent his soil samples off to 2 labs, and needless to say, they came up with different information. This was 20 years ago. So it frustrated him, and he's like, I'll just put crop removal on from now on, okay? So, and I own it, so it's not gonna go to waste. You know, a lot of people have that mentality. I own it, it's not gonna go to waste. So he's built these soil tests up tremendously well. This other ground, again, I've been saying 10, 12 years is all he's managed it. The land manager's always had us do the fertility recommendations on that because we worked with him directly. Needless to say, what this grower really wanted was he just was upset with his soil test. And I said, why are you so upset with it? Well, look at how high my numbers are, he says. And I was like, yeah, they're high. They're extremely high. How'd you get them that way? And he tells me, oh, I put on 200 pounds every year, you know, and he's really proud of how he built these soil tests. I said, so what's the issue? He said, well, the issue is this, look at this soil test. And he gives it to me. It's from the other grower's 80 that connect and farm the same for 10, 12 years, basically, other than a few tweaks with phosphorus and nitrogen and some carbon. But needless to say, he shows it to me, and it's 25, 30% of the values of this other, you know, the piece that I've been farming for 25 years. So the guy's kind of upset, and I was like, well, again, okay, I see it, and he's not explaining himself very well. I said, what are you mad about? He said, well, what I'm mad about is this piece with very little fertility, it's just junk. It out yields it by 15, 16. In fact, I think the 17 bushel, isn't it? And his wife sitting beside him. It's probably 17 bushels, the closest we've ever come to that 80, isn't it? So basically he was telling me that he had 3 times the fertility levels, but he's getting beat by it every single year, and he's frustrated with it, and he's pissed. He's like, I've spent all this money, I'm pissed. Well, I said, well, let's look at the other side of the soil test, because he's got this thing just like folded over. And if you've ever looked at one of our soil tests, the right hand is kind of the biological side, the left hand is kind of the old-fashioned soil test from universities. I said, so look at that side. Well, I don't understand that side. So we flip it over, and basically everything in the land that's been beating the crap out of it for the last 10, 12 years, had every biological function was higher. So the one guy had 85, 90 parts per million phosphorus, 450 parts potassium, and the other guy was much less, like I mentioned earlier. But on the powerful side, of the side that tells a better story, he had 3 times the carbon in his soils, and he had 3 times the biological activity in his soil. So again, what that tells you is it doesn't matter how many ppms you put in the soil if you can't get that ppm to deplete, because that means your microbes aren't working for you, and you actually can't get that fertility out into the plant. Does that make sense to any of you guys? I mean, does that half make sense? Because it's important. I mean, it's really, really important, especially if you got heavy soils. You know, heavy soils are harder to manage because everything's a balance. Like, I don't care what it is in ag. If you push too much nitrogen, something's going to, your teeter-totter effect's going to happen. You're going to hurt yourself on potassium. You're going to hurt yourself on calcium. Something's going to happen whenever you overdo anything. So it's 100% of balance. Well, in a heavy soil, it's darn hard to manage that because there's so much to balance, right? Very, very hard to balance it. So what we've gone to is really understanding when to stimulate the plant, because if you think about the basis, and I won't have time to really share a ton here in an hour, right? But water extract organic carbon should be the first thing you look at in a soil test. Why? Because it's the fuel. It's the fuel that runs the system. If you don't have it, don't buy biology, trust me, because biology is not going to work unless you've got the right biology that can actually create this carbon on its own. And you're going to hear from people at the end of the day here or in the afternoon talking about that, I'm sure. But my point is that's your trump card. The higher the amount of carbon, the faster you can cycle these nutritional balls and feed that crop. If you don't have the carbon and you go out and push too much for microbes, what you're going to find is you're going to have yield collapses. And the reason you'll have yield collapses is because any microbe you apply is always, the only way they're going to be active is if they're feeding. Okay, that's what keeps them active. So if I'm a microbe and I'm active and I'm feeding, I'm going to work for that plant. I'm going to bring that plant food because that's why I'm sitting in its rhizosphere. That's the reason why I want association, because I want every drop of sugar that plant gives me, I want to eat it. Okay? In a by process, I'm giving it back fertility. Well, once that soil runs out of carbon, or enough food source to slow that system down, you don't get the back half fed. The back half of the season, you're not going to get fed because I've consumed all the easily available sugars in this system, and now I'm slowed down and I'm basically sluggish. I had great food, now you're starving me. Once I get starved, I'm not going to work for you. So a lot of times in these programs, the most yield that's ever made in a cornfield is always going to be a week prior to tassel to 3 weeks after tassel. That's the most money you can ever make in a cornfield. Any grower that I've ever had over 350, they've been focused on that 4 to 5 week period for years. It's a huge part of it. Not to say the rest of it's not important, because you got to set the structure of a plant, you got to do things, set the roots right, that type of thing too. But you really can't have a bad day a week before to 3 weeks after. What happens at that period of time? What's typically happening at that period of time is we're going through stress. I mean, it's easy to have decent weather in May and June. Like, nothing's easy anymore, but May, June, and July. But you get into late July and August, typically we're getting hotter and drier, we got more stress. When we have stress, everything we ask that plant to do, it's costing that plant sugar to do it, everything. So when we apply nitrogen, we apply nitrate, most of us do, especially in season. Well, when that plant has to take up nitrate, it's spending a lot of its currency, the sugar that it creates within its system, to convert that nitrate to nitrite, to amino acids, to a protein, okay? That's what it's doing, or nitrite, ammonium, amino acids, peptides. It's a long chain, but my point is it costs that plant energy to do it. So not only are we going through stress, so I can't create the same amount of sugars, because a plant under stress is not perfectly healthy, right? It's not as happy, it's not as active, but it's costing me a bunch, because at that point, I'm taking up a lot of nitrogen. My point with all this is, if we've stole the carbon that's going to provide late season plant health, late season nutrition, and we used it up too early in the season, and we starve that position, it doesn't matter how much fertility we have out there, because we'll never maximize yields. We'll never maximize kernel depth. We'll never maximize weight, because we've burnt up the gas that takes to run that energy late in the game too early. So what we actually ask guys to do is to provide more gas, whether that's adding carbon yourself, that's adding humates, if that's adding humic, if that's adding boost, if that's adding carbon, right? But the other big thing to doing that is stimulating the plant. 70% of all your water extract organic carbon, again, the primary food source, is going to come from your root exudates. So the more that you can stimulate the plant at the right time, the more food that you'll provide that plant when you really need that phosphorus and nitrogen and potassium into the plant. So we're asking guys, if you're shooting for big yields, you really have to stimulate to create root exudates around B12 and BT and even potentially R1. How we manage that is how much carbon's in the rhizosphere. If I've got plenty of carbon in the rhizosphere, I don't need to stimulate that plant because I've got enough gas down there to make it operate. But if I don't, that's my job. My job is to stimulate that plant so we can create more carbon in that rhizosphere, just so we can feed that plant. Does any of that make sense? Does anybody follow your feet here? Probably a couple. So if you'd have asked me 6, 7 years ago, I would have said, man, foliar feeding is a waste of money. I mean, just junk. Really changed my mind because I was doing it wrong, didn't understand hardly anything that needed to be understood. But again, water quality is a huge thing if you're foliar feeding. I think if you, like for myself, you know, we did it for 10 years and about walked away because we weren't getting the efficacy. Finally understanding that if you manage the water quality that you're mixing it with and the time of day, and it's not just one nutrient, because again, it's teeter-totter and you're looking at a broad array of nutrients, and you understand what your weakest link is to create that sugar, you're going to have success with it. It's rare not to be 75, 80% successful now, and if I'd have been doing this 4 or 5 years ago, I probably would have been 10% success rate, just in using the same type of products. You know, it's just understanding how to use them and when is the biggest thing. What's your biggest nutrient that you fight in this country? Can anybody ask, what do you struggle with getting into the plant? Anything? I knew it was good. I didn't know it was that good around here. Potassium? Awesome. All right, great. We'll talk about potassium. So in this scenario, is this a sand or a heavy soil?
Silt loam, kind of medium.
What do you look at in a soil test to understand how much potassium to apply today? Parts per million of what? Of a malic extract or a ammonium acetate? Malic. Okay, and what will that be roughly?
50 to 150, maybe 200.
Oh, so they are that low. Is this a 12 CEC soil? Yeah, gotcha. So it's not magnesium tying it up in your world.
Some of that I can get mag up to 30%.
How much, 30? Yeah, so one thing I'd ask you to do is take your ammonium acetate number, or your malic in this scenario, and divide it by your magnesium from the same type or strength of extraction. If that's less than 0.5, then that's usually your biggest issue. It's not about a part per million anymore, it's about just can we do enough to overwhelm the magnesium, right? We use I personally believe that H3 exudates are the best for potassium. Reason being is malic and ammonium acetate are very strong, so they can rip a lot of potassium off a soil colloid, where a root don't have the power to do that. So a lot of times the soil test will show we have more potassium than we potentially do, especially in really heavy soils with high mag. The other thing is what's your pH? 5 to 6.5, gotcha. Yeah, so typically speaking, that's an easier pH actually to work with potassium. You know, where we run into the majority of our problems is when guys have a 7 pH or 7.2, 7.4, and they don't have any hydrogen present. And typically the first thing I'll ask them to do is quit applying potassium in the fall because there's no place to store it. Potassium's only strong enough to knock off hydrogen because it's a single bond. Once you get into the doubles, your magnesium, your calcium, etc., and you're applying it in the fall, basically there's no storage for that potassium. So in other words, we wasted our money most of the time. In your scenario, you can build potassium fairly easy because you've got hydrogen of probably 13 to 25%, right? So you can build it. You're just having a tough time releasing late in the game. Is that typically due to dry weather?
I think both. The tissue tests just drop off after early season, and it's not always physically deficient. Based on tissue testing, it doesn't seem to have enough. It doesn't always correlate to even medium levels of soil.
Yeah, hard to get it to correlate, right? I agree. What we do in most scenarios there is we look for, I mean, again, if you can do a Y drop, one of our best advances that we've seen is using potassium as our Y drop, and maybe you're doing this already, but like a 0013, which is a melted 0060. Put 10 gallons of that on, put 40 ounces of a 70-30 mix of humic and fulvic, and that's been a really cheap investment for us to get through a lot of scenarios, especially when there's no hydrogen present where we can't build and we have to push it later. But even in your type of situation, I think you'd see some good value. What do you think, is it the fact that you're not getting manganese in the soil, so your plant's not calling for the manganese, not magnesium, that it's not calling for that potassium? You'd think it's your soil, if it's that light, you'd think you'd be able to pull it out.
I find manganese deficiency too.
See, that's probably your bigger issue, honestly. I'd fix my manganese and see how well that adjusts your potassium pull.
Do you do soil building for manganese, or do you do foliar applications for that?
I dislike soil a lot with manganese. I mean, a ton. It's 1 out of 10 times that I can see it. 100% foliar. I try to use if I could, I would use amino acid chelation rather than EDTA, and I'd go through the leaf. But yeah, we did, like I mentioned, we do a lot of work for different companies. One of them was AgriGold, a seed company, and getting to watch what manganese does to the plant is mind-boggling. You can extend so we should talk about this. So again, components to yield in corn, right? Components to yield. First of all, you'll always beat your neighbor if you make more sugar than your neighbor does. That's a fact, right? The more sugar your crop produces, the higher yield potential, guaranteed. So it's just how do we maximize that creation of sugar? One is leaf width, leaf length, leaf color. Like your solar panels are darn important. If you've ever listened to David talk, he'll talk a lot about late in the game. He makes sure his foliars all hit his ear leaf. Like that's his leaf he wants to protect, the ear leaf and the leaf above it and the 2 leaves below it. And so he's really focused on trying to create more sugar there. And if you use manganese, manganese controls your leaf width, big time, big time. Like you can create 130, 135% bigger leaf with manganese on width. So if you're struggling with width, nail it with manganese. If you're struggling with length, sorry.
Magnesium or manganese?
Manganese, MN. Yep. Yeah, Bob sitting beside you. We did full sun studies with this AgriGold trial, and there's only 2 hybrids that we tested in 3 states that we couldn't increase leaf size by about anywhere from 120 to 145%. So it makes a heck of a difference. So when you struggle with manganese, I bet your soybeans really struggle.
Are you saying ounces of manganese or pounds?
Huh?
Probably like what kind of rates, but I struggle with my manganese products that I think have enough in them. They're 1, 2, 3% manganese, and you're getting ounces per acre as a use rate, that's like it's enough.
Well, I'm telling you, in this particular case, it's the same scenario. I just wonder, are you sure that it's not chelated too tightly?
Are you talking a micro pack or individual micro?
So, like you find a, liquid manganese that's 9% even.
Yeah.
You gotta use quarts of it to get close to a pound per acre.
Well, I don't use, in this particular case, all we're running is 64 ounces of a product that's pre-mixed, and it's a manganese and zinc and a calcium mixture. But basically, I still struggle with a lot of these 9, 10, 12% if they're chelated too strongly. It's just a leaf, again, you'd only have a few hours in the day you're going to get that thing to take it in, right? I'll tell you, we've seen the same exact product applied 3 different times during the day and watch a +9 turn into a -7, right? Why that happens is if the plant can't take it in, it's almost a foreign material sitting on that leaf. The other thing that happens is things like if the chelation's wrong, if I'm using an EDTA, it's too darn big to get through a lot of these stomates. So maybe I'd look into that because that sounds like a lot, a 9%. I use like I say, it's less than that, and we can move the leaf size big time.
Yeah, I've only found a lot of research out of Europe on it, it's challenging manganese, but they do a lot of it with wheat in Europe.
Yep, a ton of it.
They do a lot of it with wheat in Europe, and it's pounds per acre just based on their soil types and their research. I can't really find much information on manganese in our corn and soybean crops, or on soybean and corn, but it seems to be like not a lot of info out there on it.
I'll add to that though. So I spent some time calling universities wondering why did they adapt to zinc and sulfur but not to manganese and iron, and a lot of our soils don't release manganese and iron very well. This is Michigan, Purdue, Illinois. And needless to say, most of that work was done through the soil. So in those scenarios, I can see why you need pounds because you're only getting a fraction of what you apply. And the reason why is because when it's an MN2 that goes into the plant and it hits the soil, it can convert to MN3, MN4. You don't know what it's going to be in, and you don't know how long it's going to stay in there. So when you're putting pounds out, you're just hoping a fraction of that pound is available. I really think that's part of it. And I think that's part of the reason why you don't hear universities talk too terribly much about anything but zinc and sulfur. Because zinc and sulfur you can apply to the soil consistently and get that response. Copper, iron, and manganese are 3 nutrients that I never hardly get a response through the soil. So if I was the university and I tested it for 10 years and I wasn't getting a response, it'd be pretty easy to say there's no value in manganese, copper, and iron, right? But there is a tremendous value. It just has to go through the leaf to get the value. I mean, tremendous value. I'm telling you, zinc and manganese are so important in corn and soybean production. We've never had 120 bushel soybeans yet with manganese coming less than 90 part per million in the plant. I mean, it's important. It's huge for chlorophyll production, huge. And again, that's sugar, right?
Not to open a can of worms or anything, but doesn't tie up manganese? Isn't that one of the, that yellow flash in soybeans?
Yeah, I'd say that's accurate. I don't think that's a can of worms. I think that's just really accurate information. And again, if you have a really healthy environment, microbial environment, you can break down some of that problem, but it's there. There's no doubt about it. Certain soil types a lot worse than others. Exudates and biology breaks that down. If you're not getting those two things, it's tougher to get manganese from the soil to the plant.
Jason, in general in this area, we have high calcium levels,
Yep.
okay? You're very educated on breaking calcium down to get calcium to release so your other nutrients come available. You want to touch on the calcium and then also building the soybean? That's the low-hanging fruit for everybody around here. Yeah, we all love our corn. The low-hanging fruit is really on that whole soybean side of it with the calcium, even with the corn too. We want to touch on that?
Yeah, you bet. So I think it's been 8-10 years ago, I started coming to the conclusion that we struggle with calcium. After I started looking at high yields and then average yields, low yields, etc., one of the big things that was just standing out to me consistently was calcium. But yet, we grew up in an area that they say, oh, you have calcareous soils, which means you should have a lot of calcium, right? We've been taught that calcium applications are just like you mentioned earlier, used lime, right, to raise your pH. So most of us apply calcium based off of pH or a base saturation that we learned from Albright's or Kinsey, right? So that's what we've been taught. But in all reality, it's not accurate at all because just because there's calcium in your soil, it doesn't tell you how available it's going to be because bicarbonates tie up calcium. That's a fact. If you use a foliar feed and you have calcium and you put water in your spray tank that was a 7-8 and you put calcium in it and you foliared it, you'd get zero response out of it. Why? Because there's bicarbonates. That's the reason your water was a 7-8 pH and it tied up that calcium, so you'd get nothing from it. Well, our soils are full of bicarbonates, especially under irrigation. My point is, we look at two pools. We look at soil structure pool, which is your base saturation. We look at a pH pool, and then we look at what's available to the crop, and that's the H3A side. That's a root exudate side on our soil test. If we're not 550 to 700, we apply calcium. And we've had calcium applications that have had shown tremendous responses, even at a 7.5, 7.8 pH, 92% base saturation, and we still get responses to calcium. The reason why, again, is because the calcium that's in your soil is not always available, right? It ties up. We've got thousands and thousands of pounds, but it's tied up. So A, you want to acidify and break some of that down, that bicarbonate load down. But B, it's truly, we just don't have enough soluble calcium. So calcium chloride is an awesome source of calcium. There's add that with humic, add amino acids to it, and you'll instantly see a difference in calcium. If you think, I want to make sure you understand this. Calcium is definitely creating the structure in the freeway system in your plant. So what I mean by that is, when it gets late in the game, you've got to have a big, thick stalk with a huge xylem and phloem. Xylem and phloem is basically the size. We create the size. The grower creates how big of a highway system it wants in that plant. The wider you create it, the better off you are. And I could explain that deeper if you want. But what sets the stage for how big of a highway I can create in that plant for the water and nutrient transportation is calcium and silica. Those two nutrients directly tie to how big of an infrastructure that plant has as far as xylem and phloem go. Same with actually your leaf. So you've got it in your stalk, right? Xylem and phloem. And then in your leaf, you've got the exact same thing. You need nutrient sugar transportation. What sets the stage there? That's your midrib size. You want a big midrib. You should be able to drop a marble and let that thing roll all the way down, and it will never come out of that midrib because there's such a nice groove in there. Well, the bigger the groove comes from calcium and it comes from silica. So again, early uptake of calcium is gigantic. It's very important. Late passes are important because, again, we want to affect that ear leaf, and we want nutrients to move in and out of that ear leaf. So that's why we push calcium so hard, and I don't think you'll find a high yield grower that doesn't really focus on calcium. It's just hard to do because, again, late in the game when things get tough to come into that plant, move into that plant because we don't have enough sugar, we don't have as much water, you have to have a big freeway system to do it.
So you can foliar feed calcium really well?
Yeah, you can foliar feed calcium really well. You can make a difference for 10 days in a tissue. You can't make a difference for 3 weeks. You're better off in a 2x2 or a wide drop, in my opinion. We even broadcast in the right soils, but 2x2 and Y drop work most effectively for the dollar. You might spend, what's Humical cost? Is that a $10 product? So you might spend $10 twice on something that's carbon chelated, and that's what you want to look for, is something that's carbon chelated. Or complexed is a better word, I suppose, technically.
With calcium, with that chemical, you put that like Y drop.
Yep.
Does your nitrogen pass? Does that mix well? Or?
It'll mix great with nitrogen. You just can't mix it with phosphorus or sulfur. If you can mix it with phosphorus and sulfur, then it's a different form. And if you have enough acid or acid-based soils, you can get by with other forms that do mix. But the value of a calcium chloride over some of the other calciums that are burnt lime type is you don't need to have an acidic soil to make it available. It's available no matter what. Where the other products, even though they mix better with other things, so there's great value there, you have to be more cautious that you can acidify that area around it to break that calcium and create the availability. Does that make any sense? Okay.
On the soybean side of Jason,
Yeah.
we've always been kind of,
Oh, yeah.
get the soybeans in early, we understand that. But we've always been under the thing is, we'll get them tall, so
Yeah.
we'll get more nodes. Now it's more towards getting them shorter, getting them to branch better.
Yeah.
What's your recommendation on that?
Well, without a doubt, I mean, everything that a starter's been created for in the last 20 years is to make the crop more robust and beautiful, right? That's why it's built. We want to get ahead of the curve, so we're trying to push that plant. But the bigger thing is we really understand that hormonal, what we feed the plant, it's just like, I'll explain it this way. Let's just say I'm on the road all the darn time now, and I go eat crap food at McDonald's 3-4 days in a row, whatever that is. Pretty soon I'm sluggish. Why I'm sluggish is because of my diet, okay? That affected my hormones made me tired. That's just the way the body works. Well, the plant works the exact same way. You're building the diet to affect the hormones that you want. And in soybeans, you've got to be able to express your cytos in your plant, which is a hormone. Cytos are going to create your branching and your fruiting nodes and more stacking in your plant. So I always like to explain it like this. I want a short, fat plant. The shorter, the fatter the plant I create, the higher the yield potential I'm going to get, because I'm going to create more nodes per acre, and I can move nutrients and sugars more effectively than a plant that's this darn tall. This darn tall looks good, but it's hard to manage it because you get too much length in between your internodes. And typically speaking, you're going to lose on internode count on a per acre basis. What we're really trying to manage in this scenario is how many nodes can we create per acre, because nodes are going to give us the opportunity for flowers, flowers are going to give us the opportunity for pods, right? So we're trying to manage them nodes. On a main stem, you're only going to get between 20 and 22 nodes. If you want to get to 130, 140, 150 bushel beans, the only time I've ever been involved in it, again, it's when we get the branching to happen. You'll never get branching to happen if you force growth too early with things like phosphorus, potassium, nitrogen, sulfur, because they're elongators. They're driving auxin growth. Auxin is a hormone that pushes vertical. Cytos are going to push short and fat. So your diet affects how that plant's going to express or what hormones it's going to express. So like for instance, if I'm using a soybean and I'm trying to push for high yields, the last thing I really want in it is potassium or sulfur, because they're going to push growth. What I want to do is limit growth, get a deeper root so I can promote more of my cytos. And again, that happens with the correct diet early. You know, I'll use what Greg McClure says. Greg says, how many guys know when you determine rows around in corn? Everybody know? Kinda? Raise hands, unless everybody's sleeping. So most guys know that, right? We've been taught that pretty darn well. But in soybeans, we know a lot less. Like, again, length of corn, it comes V8, V9, right? We know the components of yield in corn, but components of corn and beans is a lot tougher. But actually, what we found, and Greg's been a big part of this, there's been a lot of people that have helped in this, it's you can't express, or you're not gonna have an effect on node count after V4. So when that bean plant's this tall, you've already determined how many nodes you're gonna create. Nodes is a bigger issue to me than what my girth is on corn, but we've all known, again, girth of corn when it's determined. But nodes have a heck of a lot bigger influence on your final yield than that of kernel count early. But yet again, none of us have probably known that. I doubt anybody knew that in this room, because I didn't know it until 3-4 years ago. So my point is what I just told you expresses how many nodes we're going to create is how we manage the hormones. How we manage the hormones is a diet. So it's starting that thing off right is very, very important if you want to maximize node count. And the other thing is population, right? It's very hard to manipulate a plant that's planted too thick because they're competing for sun and they're always going to grow tall, and that's just the way it is. We create a zone system and we variable rate our soybeans from, like I'll give you an example on our own farm. I'm not saying this is for everybody because it takes some risk tolerance, but we'll variable rate ours from 50 to 140, okay? So 50,000 is going to be in our highest producing zones, and 140 is going to be on our hilltops, because in all reality, we're trying to have the same amount of nodes on a per acre basis across that farm. We know our hills won't express enough nodes, so we might only get 11 to 13 nodes on a main stem on a hilltop in our world. But our swales can be 20, 22, so we have to adjust the population so we can have even node count across the entire field. Is that kind of what you're after on the soybeans, or do you want deeper than that?
That's the basic of what we're gonna get at
Okay.
in that regards, because that's contrary to what we've always been at.
Yeah.
Okay, it goes back to, that slide that I had up there, it's a moron approach.
Yeah.
Just put more on.
Yeah.
So it's kind of contrary to what we've seen. We set a personal on-farm record, and we had some farms that were absolutely horrible that we took over. Because there is one major soil testing lab in Minnesota that shows over half of the soils in Minnesota are low on nutrients, the P and the K.
Mm-hmm.
Okay? And that's what we're used to, but a lot of people in here rent a lot of land, so you can't just put more on. You got a couple $100 out there, $1,000 to start getting yields going, but you run a real good chance of losing them.
Yep.
Okay? So now how do we compensate for that? And that's what I was getting at with that. There's some things now that the technologies are coming along that we can do rather than just the moron approach, you just put more on.
Yeah, more on doesn't work very often. I mean, it's only going to stay in solution a certain amount of time, right? So if I put 1,000 pounds or I put 100 pounds, it's only going to stay in solution before it fixes so long. So it's more about how do we solubilize what's in our soils. But back to the soybean production, another thing that's very, very, very important is phosphorus. Phosphorus, what you want to do in any crop is you want to get into reproduction faster. Right? The faster I can get into reproduction, the more yield potential I have, because when I'm in reproduction, I'm putting all my energy towards grain fill, right? Or pods, or wheat, whatever it is. It's grain. When I'm in vegetative, I'm putting into growth. So the happier I am when I'm in vegetative, I'm just going to get taller and taller and taller. The happier I am in grain fill, I'm going to put it, into grain. So we need to make sure that we're getting that plant into reproduction faster, and phosphorus is a big part of that. One thing on soybeans that I know you'll find very valuable is there's two things I'll share with you. One is the highest yielding soybeans will always come from the highest carbon amounts in your soil. If we just pretend like we grid sampled this room every 4 foot, I'll bet I could come within a couple bushel of predicting if you gave me the average of where the 100 bushel beans were, where the 20 bushel beans were, just off that one test, because carbon drives nitrogen creation. Because again, nitrogen creation comes from carbon. Bacteria doesn't just build your nitrogen for free like we think. It's an expense to build nitrogen for soybeans, and that expense is, if I'm a bacteria and I'm creating this N for your soybean plant or any legume, I used your carbon to do it. I had to use your carbon to make this nitrogen. So it's in a very expensive form of nitrogen, actually. Even though we think it's free, it's not free because we've been using carbon to do it. But my point with high yielding soybeans is you've got to have a ton of carbon to create enough nitrogen to get to 100 bushel beans. A ton of carbon, because again, it's 5 pounds of carbon to every pound of nitrogen. So my point is you could grid test this area and you could nail where your highest yielding beans are going to be to within 5 feet because of the carbon test, period. That's the big driver. The next thing is that phosphorus. That phosphorus part has to happen a week prior to R1, basically through R2.5. If you can't maximize phosphorus at that window, you slough a lot of flowers. The higher your phosphorus content, a week prior to R1 to roughly 20 days after R1 will truly tell you your conversion rate of flower to pods. And that's important. I mean, it's really, really important. In fact, you've probably seen some of this data, but some of this data supported that if you couldn't put a flower on it, you should have just clipped it. Like there's actually a study showing if I didn't put a fruiting flower on that converted to a pod, I went and clipped that out and I pruned it. When I pruned that soybean plant, I got higher yield because I didn't want to support something that wasn't going to give me yield, right? So I was just wasting energy on that whole lead or that whole lateral. So I'd chop that thing off and I'd create more yield. So if you're not fruit bearing, then you're wasting energy. remember that grower that I talked about, that young grower that came back, wanted high phos levels, beans. I tried to talk him into no-till, so in about 3 or 4 years after I tried to talk him into it, he was out planting his spring crop, and he called me and just chewed my butt like hardcore. He's like, you get out of here, you think it's so, I can't even get the planter in the ground, right? Okay, I bring that up only for one reason. Rotation has a heck of an impact on what we should be doing for tillage, in my opinion, right? The lower the carbon to nitrogen ratio, the harder the ground becomes. No-till doesn't work in that scenario at all. We have to get oxygen deeper. So in my opinion, no-till works if I've got a diverse rotation where I'm getting carbon deep and I get oxygen deep, but it's not the answer, all I'm saying. It's not like this holy grail if you don't. I had a guy one time just really running down his neighbor for tilling, and I said, I bet you what you're doing isn't any better. And we're good friends. So this wasn't like I wasn't trying to fight the guy. I'm just telling him, I bet yours isn't that much different. He goes, why the heck wouldn't it have been? I've been no-till for 20 years. It's 23 or 4 years actually. And I said, because you put all that darn nitrogen on the fall. That darn nitrogen is burning up carbon just as fast as that tillage is. So we go out and we soil test, and this is again right to the row. All we do is jump the fence line. He's with me. We both do it. There was a slight difference. Joe's was a slight amount better than the guy that was tilling every fall, but it wasn't much because again, same rotation with a lot of nitrogen in the fall. So there's a million ways to destroy carbon. And so tillage isn't the anti-thing. If you can't get oxygen into the system and you don't have a rotation enough that you can get carbon deep, I like a chisel. That's my go-to. I love a chisel. I dislike vertical tillage a ton, but I really do like a chisel. Just adds a lot of opportunity and a lot of lift. And I don't want to turn soil. I'd rather lift and let it fall. Because I don't want to change my aerobic conditions, really. I'm trying to get my aerobic deeper is what I should say. When I flip soil, if you've got really good heavy soil, that can work, but a lot of ours, we lose some of our values and our humus isn't there in the deeper soil, so I really don't want that poor soil on top. And the other thing is pH changes a lot in every 6 inches. You know, I'm going to use my examples in North Dakota. In North Dakota, we actually will flip that ground after they've anhydrous and they've got really high pHs. They might be a 7.5 to an 8.5 pH. What we'll do is we'll flip the soil because we have a lower pH at 6, 8 inches deep. That's the opposite around here. Typically speaking, we'll get more calcium the deeper we get, and the higher pH we go, the deeper we go, right? So you got to have to be a little bit thinking about the pH change too and what we're going to do when we flip it. Any other questions?
I know around here with the soil test or with the tissue test, especially with the corn, we see it really drop off there right at that VT-R1 stage. Yep. You got any recommendations on how to keep that up?
Yeah,
instead
for sure.
of letting that drop, because that's really pulling into the gear.
Yeah, that's exactly what I was getting at earlier with the carbon. We watch it every year. Carbon crashes, nutrient drops at the worst darn time, right? So A, you can address that with more soluble nutrients, or B, you can address that by stimulating the plant to create that gas again. But if you're gonna do it, like I say, we do a couple way approach. So typically speaking, we're gonna get 2 foliars in a year, and we're gonna get 2 wide drops, or a side dress and a wide drop, because it's hard to understand what my yield potential is this time of year for next year. So we adjust as the yield potential changes and the weather changes. And then B, again, in dry years, it promotes certain nutrients. Wet years, it promotes other nutrients. So even though a soil test is great, and we own a lab, and I'm pretty proud of what we do, it's not perfect, right? So we have to make some adjustments in season, and typically that comes right at that time. We're trying to do it 10 days prior to tassel, 2 weeks prior to tassel, get that tissue in that soil and adjust again.
Okay, I know there's only a couple, but I know there's a few that in here that use irrigation.
Yep.
Okay? In that regard, fertigation, what's your opinion on success with that or whatnot?
Great with the right nutrients. I mean, first of all, know your water quality, again, like I said earlier, because a lot of us can't get away with certain nutrients. In fact, we do a ton of work in Nebraska. A lot of work there. And obviously there's a lot of irrigation there. What we've learned is it varies on region and well and how deep that well is on what we can get away with through fertigation. But some things that are very good at through irrigation would be boron, would be nitrogen, would be sulfur. Potassium's even pretty darn good with irrigation water. Things that are really poor is magnesium, calcium, copper, iron, any of your real light micros. Boron is an exception to the rule as far as a micro that works through a pivot. Yeah, great question.
How are you doing that?
So when we originally started, we were just using it as a composite, truthfully. I mean, again, all I was doing is trying to help the grower make a better decision. Realizing now, 5 years later, that that was the way wrong thing to do because it varied from, you know, me to the bar. You know, so what we do today is we do zone samples. And our zones are based upon a couple things. But the primary goal of that is to understand mineralization rates. So we rank our soils 1 through 10. A 1 is going to be your high and dry soil. Let's just say it's tabletop flat. Then it's just going to be the lightest soil in that tabletop flat area. Your 10s are going to be your heaviest soils. And the reason why we do it that way is because we want to understand how long does our soil stay wet across that field after an inch of rain, because that tells us a lot about the mineralization potential. So we segregate our soils based off how heavy they are, how light they are, and then the topography and the slope of the topography, how you know, if it's a sharp slope or if it's a gradual slope or if it's a north-facing hilltop, etc. And we create a zone system 1 through 10. Then we combine 1 and 2, call it zone 1, 2 and or 3 and 4, call it zone 2, and we manage 5 fertility zones throughout the season. So we're only soil sampling 5 zones on a typical quarter, even though we created 10, just because, again, fertility equipment isn't perfect, A. B, you got to spend, you just can't outspend yourself either, just trying to learn things. We use 10 zones for seeding though. It's spacing more than you know, so it's plant to plant spacing is really what you should focus on rather than caring too much about, you know, if I'm 30s or I'm 20s. It's really how many inches do I need around each plant to make it happy. That,
135,000.
yeah, so again, if I was 135,000, I'd want 10-inch spacings, you know, or 10-inch rows, truthfully, because I can get more space around each plant. But back to the real answer, the best way I can answer that is it depends on region. Like in South Dakota, there was a huge shift to 20-inch rows. We probably had 45, 50 growers that went that direction, and I've already went back away from it. Why? Because we're hot and dry. What that means is at night times when we cool down, when we are hot and dry, we need that coolness from the night to penetrate our canopies, okay? And if it's not dropping the canopy temp, we burn up faster. Okay? So in other words, an example of that would be, there's times if we're really drought stricken, we might have 100 bushel 20-inch rows on the outside of the field. We get in the inside at 65, 70. They'll drop 30, 40 bushel. Why? Because we couldn't get enough penetration of cool. We couldn't cool that canopy down with a 30-inch, had more room to cool down. So it varies on your area. Spacing wise, 20 inches are great. They're easiest to manage, easiest to establish everything we want in a stand. I love them soybeans. There's a lot of things I love about a 20. But if we're in a hot, dry area, there's times it beats us up. So that's a tough one to answer.
What about solid seeded?
I care too much about spacing for solid seeded, in my opinion. I mean, I've done a lot of studies with Precision and John Deere and even another off-brand company. And you know, you can gain 8 to 10 bushel pretty easy on spacing on soybeans, and we've known that we can do that on corn. So solid seeding for me doesn't typically. I don't like it. I mean, I want to create a vascular system and a structure that I can handle stress late, and just not controlling my depth well enough eliminates that opportunity. Depth's a big deal on soybeans and corn. Well, thank you guys.
Okay, thank you, Jason.